Write a balanced equation, including correct formulas and states of matter, for the decomposition of solid sodium carbonate to produce solid sodium oxide and carbon dioxide gas. For a question like this, you're taking a lot of information that's in word form and you're going to convert it into chemical nomenclature using a number of different rules that we've now discussed in class. Okay, we're going to be hunting for a lot of information in this worded description. So to write an equation, the first thing we need to figure out is what are the reactants and what are the products. If we read this, it's going to say, decomposition of some stuff to produce some other stuff. In other words, the stuff that's decomposing, that's what we're starting with. That's going to be a reactant. The stuff that's being produced, that's going to be the products. Okay, so we've got that identified here, so let's write that stuff down now that we know it. Sodium carbonate is our reactant. Our products are sodium oxide and carbon dioxide. Okay. The next thing we need is the formula for each of these things. Okay. So we're going to go through one by one and figure out what each of their formulas is. This first one fits the pattern of an ionic compound. It lists a cation and then an anion. And so it's going to form an ionic compound following those rules. We need to think individually, what is the sodium cation going to be and what's the carbonate anion going to be and how will they come together. Looking at the periodic table, sodium is Na. It's in group 1, and by the octet rule we know that it's going to lose one valence electron to reach the nearest noble gas electron configuration. That'll give it a 1+ charge. Carbonate is a polyatomic ion. We can look that up in a polyatomic ions table in a textbook or in some other handout. We'll look it up and see that it's CO3 2-. Okay? So when these two things are going to come together to form an ionic compound, they form a compound such that the overall compound itself has no charge. So all of the plus needs to cancel with all of the minus. As written here, we have 1+ and 2-. For this to work out, we're going to need 2 of these 1+ to cancel every 2- that we have. That means there needs to be 2 sodiums for every CO3. We write that like this, Na2, CO3. That's sodium carbonate. We go through a similar process for sodium oxide. Sodium forms Na+ ions. We know that from the octet rule. Oxide is not polyatomic. It follows the rules of naming for single atom anions because it has an IDE ending. So we look at oxygen on the periodic table. It has 6 valence electrons, and so it's going to want to gain 2 valence electrons by the octet rule. Gaining 2 electrons will give it a 2- charge, so we're going to get O2-. For these two things to balance in an ionic compound, just like before, we're going to need 2 1+ to balance every 2-. So we're going to need Na2O as the formula of the ionic compound. Carbon dioxide is not an ionic compound. It's all nonmetals, carbon and oxygen, so it doesn't follow those rules. The formula for carbon dioxide you can see from reading the word carbon and then diamine 2 oxygens, like this. Okay, so now we've got formulas for everything. We need states of matter next. That's going to be in the worded description somewhere. So sodium carbonate is a solid. Okay, that means it gets a little S. Solid sodium oxide, that gets a little S. Carbon dioxide gas gets a G. Okay, we've got formulas, states of matter. We know what our products and reactants are. The last step then is going to be to make sure this thing is balanced. Okay, writing a balanced equation, what we want to do is we want to count how many of each element are in the reactants and how many are in the products and make sure that those numbers are equal. Before you start balancing, check what you have. We have 2 sodiums and 2 sodiums, 1 carbon and 1 carbon, 3 oxygens, and then 1, 2, 3 oxygens. So guess what? It's already balanced. Now we're finished with this problem. This is the reaction that's described above.